how much serotonin you make when you get UVA light in mid-morning is going to dictate how much melatonin you can make later when you block blue light after sunset. So the storage of serotonin, that's going to be converted to melatonin later. So I tell people your good night's sleep starts with UVA rise so that you can get the melatonin. And the melatonin, again, is going to help you signal to go to sleep, but then have deep healing sleep as well. And DHA has what's called a pi electron cloud around it. And when light hits that electron cloud, it excites it, and it literally creates DC electricity from that. This is what Einstein described as the photoelectric effect. That's what DHA does for us, which is why it's concentrated in high amounts in skin. And it's no mistake that the foods that have higher amounts of deuterium are typically available either in the season where there's more sunlight, or if you live in a place where there's sunlight year round. And that's for a purpose because our body is able to deplete deuterium through sunlight exposure. But if, again, we are eating foods out of season, in Virginia where I am, I'm eating oranges and whatever, then I am accumulating deuterium that could be breaking my mitochondria, and I'm not able to deplete it as well because I'm not getting as much sunlight.
When it comes to pain, let's talk about going from normal, healthy response to when it becomes pathological.
We think of pain as a bad thing because it's so uncomfortable, right? And we don't necessarily want it. And as soon as we have it, we want to get rid of it. But it wouldn't be there if it didn't have a purpose, right? So there's a reason for pain, and it's to signal to us that there's something wrong and that we need to pay attention to that. Whether it's the tissue on our body that's been damaged and we need to pay attention to that tissue, or it's something that's hurting us and we need to pay attention to that thing and make sure that that thing goes away. So it has this very important role in the body, and it's very evolutionarily preserved because there's many different pathways in the brain that can signal for pain, which is why they have trouble making pain drugs, because there's so many different pathways. You can't just block one and expect pain to not happen. But so the body is like, this is a very important thing to have. And there's actually people that are, I would say, unfortunately, born without an ability to feel pain. And you'd think that that'd be great. Oh man, this is amazing. But these people actually don't live very long lives because they die of different complex issues that arise from them getting injured. And, pain teaches your body something. It teaches you to avoid that painful thing in the future if you have the correct response to it. And so if you don't have that pain signal, you don't learn to avoid painful things or learn to avoid situations where you may inflict damage on your body. And people would say like, well, can't they just learn that? Can people just tell them, hey, this is going to be a bad thing? And it's kind of similar to like, I think we've all, had the experience of, especially when we're kids, like of our parents telling us, don't do that because of this, but we do it anyways. Why? Because we have to figure it out for ourselves. But in the process of figuring out those things for yourselves, you learn about that. And then you don't do it again in the future. You taught yourself your lesson. But if you don't have a pain response, you can't teach yourself that lesson. And so these people continue to get injured. They have issues from those past injuries, and they tend to die much sooner in life. So pain is a normal thing in how it informs us. It's one way that it informs us about our environment so that we can change our behavior and avoid that in the future. Chronic pain is not a normal thing because there's really no, advantageous purpose for pain to be there chronically, to always be there. So that is something that is a direct result, in my opinion, of the very changed way of our modern way of life. From where we used to be living in nature, and even then, when we had civilizations, we were much more in touch with nature in different ways, and we've divorced ourselves from that. And so it's a direct result of us being out of those environments, and it's leading to things where a pain signal, and there's different ways this can happen. A pain signal can be chronically stimulated, or your body's chronically getting the signal to create a pain signal in your tissues with no physical damage being there, or physical damage having happened in the past, or physical damage happening inside of us, that I'm sure we'll talk about as far as like cellular health and things like that are making the brain perceive that there's a problem and we need to create a pain signal. And that's where chronic pain comes from. So that has to do with our entire environment, everything our body comes into contact with every single day.
Do we know at this point if humans are the only species to have chronic pain?
I don't think we can say for sure, but I don't know. It would seem unlikely that other species have chronic pain from my perspective, because the prefrontal cortex and the size of our prefrontal cortex is really what creates a pain signal. Or it's one thing that can perpetuate this pain signal even if there's no physical damage happening. And other species don't have the size prefrontal cortex that we have. I mean, our closest relatives are, various apes and chimps and things like that. And they still don't have near the level of prefrontal cognition that we have, that allows us to almost think our way into a pain response, depending on many different factors. But I think that a chronic pain could definitely happen in other species if it's a more of a sensory pain signal. So a chronic sensory stimulation. So basically, let's say there's damage to a tissue. Maybe it's degeneration. Maybe it's just, especially like our pets, maybe they're being fed processed food diets or things like that. And there's just this low body charge or low cellular charge. And that could be sending a chronic sensory pain signal, which is we can see our pets be uncomfortable as they age, So that's one way. But I don't think that a chronic pain of a cognitive nature exists in other species. I have no proof of that, but it doesn't seem like that would be possible based on the mechanism at which that happens.
Let's take an example here and get practical. So say we can use any injury that's been chronic in the body. We'll just say chronic knee pain. It's been there for a few years, somebody tuning in today, and they want to begin to uncover what is at the root of that, and then what they can do to start to unravel and get rid of it.
Yeah. When someone has a pain that may not be like chronic, but it's sticking around, let's say it's been a few months and you just started having this pain, like that would be chronic technically, but it wouldn't be like lifelong chronic pain. But it's not going away. So we have to investigate why that is. And so I like to break this down for people. There's 3 different aspects of pain that are important to understand before you can start to address, or you have to understand this before you can start to understand why you're having this pain, so you know what to do to fix it. So if you get damage to a tissue, like you cut your skin, or maybe degeneration in your knee, or something like that, that can, if you get physical damage, like you cut your skin, you're always going to get a pain signal. Degeneration, you may or may not get a pain signal. But something increases the likelihood that we'll get a pH change in the cells in that tissue. So pH change means it becomes more acidic. You could say that the cell loses its voltage. Something happens, and when that happens, it loses its pH. That chemical change signals, your sensory nerves pick up that signal and carry it to the brain. And the brain says, okay, something's wrong. And it sends a pain signal back down to that area to say, hey, this area is damaged, pay attention to it. And that's very important, again, for making you pay attention to it. So you change it. But that's where the saying pain is in the brain comes from, because pain is not happening. Like the sensory, the tissue here is not signaling for pain. Your brain is signaling for pain to be there. So it has to get that signal first. So that's sensory pain. That's how it works. And there's different levels of neurons through which that are communicated, to the spinal cord, up to the brain, to the sensory cortex, and then back down. So that's sensory pain. Now, very tied to those sensory pain centers in the brain is the emotional centers of the brain, which is why when we feel pain, we tend to have a emotional response to it. And it's usually a negative emotional response to, we cry or we get angry, like, ow, that hurt, and this emotional tie to it is very important, because that's what teaches you to avoid the pain in the future, avoid the thing that caused the pain in the future, that negative emotion. And this is also very evolutionarily preserved, because even if the person that we love most in the world accidentally hurts us, by stepping on our toe or something like that, as much as we know it was an accident and as much as we love this person, we're still kind of mad at them. Then they were like, how could you be so clumsy to step on my toe or whatever, because that emotional response is really what's teaching us to avoid the pain in the future. So that's the emotional connection to that. And then then there's the cognitive aspect of pain, and the cognitive aspect of what, especially for humans, is really what allows us to worry about things, this prefrontal cortex, this cognition, and to wonder about meaning of things. And so when we do that with pain, we're actually overdo that with pain, I would say we're actually wiring that emotional and cognitive centers together. So we're worrying so much about it, and our prefrontal cortex is allowing us to worry about the pain. So if it happens chronically, we continually worry about the pain, and that's wiring things together. The emotional centers, it can actually happen backwards. We can actually cognitively think our way into a pain response because the emotional centers get activated, then the sensory centers get activated, and the brain sends a sensory signal back down to the body. And there may not be any physical trauma there anymore. There may not be a chemical change. The brain's getting the signal to do that. So yeah. And so I should also say that the sensory pain signal is pretty much in all animals, even invertebrates, like, very small, like flukes or bacteria or things like that. They have this ability to sense pain and go, ow, and kind of get away from it. But only vertebrate animals have the emotional aspect of it. So anything with a spine, any animal with a spine is going to have the emotional reaction to it that teaches it to avoid it in the future, which is helpful for survival. But then I would say that chimps and some species with a little bit larger prefrontal cortexes probably have some ability to worry about it. But humans are very distinct, and we have a large ability to worry about things and wonder about things. And so this is kind of unique to us. This cognitive aspect of pain, I would say, is unique to us. And so when someone's dealing with a knee issue, let's say their knee is chronically hurting, it could be as simple as just a overstimulated or chronically stimulated sensory pain signal. So something about the tissue, the cartilage in that knee, or or even the bone, but especially tendons and muscles and things around it. Something about that is chronically decreasing the pH and the charge in that tissue, and your brain is always getting a signal to create pain in that knee. And so that could be as simple as treating the muscles with electrolytes or something. It could be as simple as charging up the body, like putting your feet directly on the earth and gaining some negative charge. It could be as simple as red light or in sunlight or something like that. Just anything you can use that will increase the charge of that tissue, or creating better metabolic health, not being insulin resistant. So eating a more whole foods diet and setting your circadian rhythm, creating more metabolic health in those ways could increase the charge of your cells and prevent that from happening, that pain signal from happening. Now, that would be more of like the knee pain started 2 months ago and it's not going away. That would be my guess. That would be where you would approach it. If you've had chronic knee pain for years, it could have started as that, but it's been around for so long that you've wired the cognitive and emotional and sensory areas of the brain together because it's been there so long, and you've worried about it so long, you've been dealing with it for so long that you've wired those things together. And if you do that sensory stuff that increase the charge in that tissue, you do some grounding, you get infrared light, you fix metabolic health, that could significantly help. But there still may be some brain rewiring that has to be done. You could still get that pain because it's been there for so long and your brain wired that way. So that's kind of how you would have to look at things and address things is how do I fix that based on how long it's been here? What's my current environment? How long am I going to have to go? And just have to start trying things. You try the sensory pain, the charge up your body first. If that works or improves it, that was part of it. If it doesn't help it all the way, we may have to address some more cognitive things. Yeah.
All right, let's stick with the foundation there and charging up the body. We have the food we're eating, grounding, and light. Let's start with diet. Somebody that wants to assess where they're at and make better choices, how do they begin there?
With food, I'd say that like my general recommendations for diet are eat whole foods and eat as organic as possible. So I'm partial to animal foods. I think that they are the biggest bang for your buck. They're what humans have been eating for however long you believe humans have been on Earth. You get their most bioavailable. We are animals. We are made of animal. So when you eat those things, you make yourself from it. Eating whole foods in general, though, is really going to help contribute to good metabolic health. So generally, like, I don't think carbohydrates are evil. I don't think we should eat a ton of them because if we lived out in nature today, we wouldn't have that many carbohydrates available for us. So it probably wasn't a huge part of humans' diets. It was just kind of here and there. So, but if your best bet there is whole food carbohydrates and not processed carbohydrates, grain, sugars, things like that. So that's going to be like, for some people, that's like 70% of the battle, because I think that disrupted circadian rhythm is largely what's driving poor metabolic health and changes in mitochondria that allow them not to function properly and creating these poor metabolic issues. And then I think that when you add a processed food diet or standard American diet to that, you're adding fuel to the flames. And so if you take away the fuel to the flames, you're going to feel a lot better. You're going to create a lot better metabolic health, but the embers of the fire may still be burning, if you don't optimize the circadian rhythm. But so that could be, like I said, 70% of the thing. You're taking away the fuel to the flames. And so that's going to create better metabolic health. And when you create better metabolic health in your mitochondria, they're going to increase charge of those cells much better. So, with the purpose of metabolism is to harvest the chemical bonds or break down the chemical bonds of food to harvest electrons from that food, so you can use those electrons to pass down the electron transport chain. And that's used to make ATP, to unfold proteins, to structure water, and the structured water is what holds the charge. And so if you want to hold the charge in your cells and make it much less likely that you receive a pain signal from that tissue to the brain and back down, you want to build the structured water. And the mitochondria make metabolic water. They make structured water. And so they also need proteins to attach themselves onto and hold the charge there. So that's what the ATP does. It unfolds the proteins. And this is all optimizing metabolism. And so from a food perspective, the best way to do that, I say, is center your diet around animal foods, add variety with plant foods, and make sure they're whole food carbohydrates if you do carbohydrates, or lots of them. And I would say eat in season. You eat plant foods in season, and that would be where to start.
I want to really drill down into this in season with the plants, because you have a really deep, nuanced view of this. And to me, there's two different aspects from reading your book. One being the imprint from the sunlight, and two being deuterium. Mm-hmm. So bring both those aspects in, and why local is so important.
Yeah.
Specifically for plants.
Yeah. So local and in season, really important for exactly those two things you mentioned. So first, plants kind of have this mechanism of, because they're so tied to their environment, they can't move around like animals can. They imprint the light environment into their I want to say tissues, but into their plant substance, whatever it's called, but into their plant substance, because they're so tied to that light environment. And so when you think about electrons, what you're thinking about is like when the sun hits your body, you're making electrons from that sunlight. And so that sunlight, that electron has that kind of that light signal stored in that electron, or kind of communicated in that electron. It's kind of a communication, a path of communication. So when plants are grown in a certain environment, and then you eat those plants, and then you harvest electrons from those plants, then the light environment from that plant, wherever it was grown, is now being kind of almost downloaded into your physiology, into your mitochondria. And if your mitochondria, your infradian rhythm, the light environment of the mitochondria and how that changes through the local day-night environment of your external environment where you are, is different than the light information that you just ate from food that was grown who knows where, because we have food shipped all around the world, it can create confusion. It can create a little bit of mitochondria uncoupling. And those confused signals create just that confusion in your body. So there's a lot of people who go on carnivore diets, and there may be a lot of reasons why they see improvements in their health, but people say, oh, it's the plant toxins. They're eliminating plant toxins, or maybe they're eating a very low deuterium diet, which we're going to get into next. But it could be that they've just eliminated this different programmed or downloaded light signal that they're getting. That could also be a contributor. So that's why it's important to eat local and in season, or one reason why. So you get similar light signals from your external environment and from what you're eating inside. So the next thing is the deuterium. So our deuterium is a heavy hydrogen, they call it. It's a separate isotope of hydrogen. So everybody, well, not everybody knows, but like it's commonly known that electrons are passed down the electron transport chain, and then that generates hydrogen ions that go up into the inner mitochondrial membrane space, and they come the other way, and they go back to complex 5, and that's what generates this ATP production. And so the deuterium is an isotope of hydrogen that has an extra, I might get it wrong. It's either proton or neutron. I think it's neutron. And so
it's a neutron.
Yeah, neutron. So it comes back across and it tries to go into the ATPase complex 5, and it clogs it up because it's not hydrogen, it's heavy hydrogen. And when it clogs it up, you stop making ATP. So it basically kind of breaks your mitochondria in a way, or makes them less efficient. So that's an issue, because then you're not making ATP, you're not unfolding proteins, you're not maintaining charge and structured water. And so deuterium is found, it's going to be found everywhere. I mean, there's some in animal foods, there's some, there's much more in plant foods. You could eat deuterium's even present in water, but there's kind of this hierarchy of what has more deuterium than others. And it's no mistake that the foods that have higher amounts of deuterium, plant foods, things like fruit and even vegetables, are typically available either in the season where there's more sunlight, or if you live in a place where there's sunlight year round, you're going to have that food year round. Like in tropical areas, you can have fruit year round. And that's for a purpose, because our body is able to deplete deuterium through sunlight exposure. So if you're eating those foods and you're also getting ample sunlight, your body's able to kind of get rid of it. Or also generally more toward like water from springs that's more toward the coast, which generally could be warmer, depending on where you are on the earth and on the coastline, is higher in deuterium, rather than water from springs off glaciers or in mountain springs have much less deuterium. So it's all kind of environmentally appropriate. But if, again, we are eating foods out of season, we're having fruit shipped all over the world, and in the middle of January in Virginia, where I am, I'm eating oranges and whatever, then I am accumulating deuterium that could be breaking my mitochondria, and I'm not able to deplete it as well because I'm not getting as much sunlight. So even if I was getting a ton of sun in the winter, it's not as high of an angle. I'm not getting as direct sunlight as I would be in the middle of the summer. So all that stuff's important. And I think, it's playing a role in why we're so chronically ill, why we have this chronic metabolic dysfunction, because we're eating these foods from grown all over the world out of season and not local to our environments.
So the ultimate example here, you gave an example in Virginia, but just to expand upon that, is say a strawberry in the winter grown in California. It's going to get that imprint from the sun, and then say it's shipped up to me in Ontario. So I'll have the wrong imprint from the sun, and it's going to have the deuterium. I'm not going to be getting the amount of sunlight I'd be getting in the summer here. So I'm going to be getting hit by both negatives. So the important highlight here is the fact that somebody in a different part of the world could be thriving on a certain food, whereas somebody like us in the winter up north, that food could be causing all kinds of problems. So it's not as simple as this food's healthy, this food's not. This is the nuance that is so important to bring about, because not a lot of people are talking about this.
Yeah, it's incredibly important. And it also just makes sense logically. Like you were just saying, like when you say it like that, it just makes sense. Like we never would have had foods available that probably weren't within a few miles of when we woke up that day. They weren't grown or raised there, or just happening naturally, wildly. So yeah, it makes sense. And then you think about, if we're eating foods that are just like you're saying, like if this people in the tropics are eating these, amazing foods, and we attribute the benefits of them eating that amazing food to the different nutrients, like it's high vitamin C or something like that, and like acerola cherry or something like that they're eating this high amount of vitamin C. We're like, oh, that's got to be why it's beneficial. Well, maybe it's beneficial to them because they're in the right environment to eat that food. It doesn't mean it's going to be beneficial for everyone all over the world. It's incredibly tied to our local environments, light and everything else. So, I mean, and there's also just arguments too of just like it's not going to have near the nutrients it would have by the time it gets to you anyways. So it's not the same food as when you picked it fresh. So yeah, it's but it's just logical. Like we have to kind of account for that. And like I said, when people go on these carnivore diets, I think that, a lot of the benefits they attribute to maybe just better nutrient absorption because it's more bioavailable, or maybe it's just avoidance of plant toxins. But I think the light has a lot to do with it as well. And deuterium has a lot to do with it as well.
You brought up the piece of shipping these things across the world and losing nutrients. That, along with the emissions and the environmental impact, seem to be the two common arguments for eating local. And now you've just brought in two other important pieces in. Again, getting into detail here that's not often talked about.
Yeah, it's not just beneficial for the planet, right? It's beneficial for us, our local planet. I think of us as like a planet, right? So we have to take care of it. And what's usually what's best for the planet as a whole is best for your little local planet as well, generally. And that's one example. Like, if we're eating more local, we're not shipping things around the world, that's better for greenhouse gas emissions. It's better for quality of food. You don't have to spray as many chemicals or preservatives or things on food when you're eating them local. So that's just all better for that kind of stuff. Economically, it's cheaper. But also it's just better health-wise, like we talked about for us too. And that's generally how it goes when you think about that kind of stuff.
Coming back to the imprint piece, sunlight causing an imprint on plants. The other aspect you bring up in the book with that's detrimental is to the gut lining. Talk about that connection.
Yeah. So, when your bacteria in your gut are breaking down the food so that you can digest it, so it can be absorbed through the gut lining, light is being emitted. So because again, we're breaking it down to harvest the chemical energy, the chemical bonds that store the energy. So when they're getting broken down, they're releasing light. And the bacteria in the gut, they don't have like light receptors in their cells like we do, which means that we're absorbing that light and the bacteria is not. And so the gut lining is taking it. Kind of think about like a projector screen, like going on to the lining of the artery. And again, if the gut lining is kind of like an external environment inside our body, or it's supposed to be kind of sealed off. So we're kind of like a donut if you think about it. And so if that external environment is getting a very different signal in the gut than our external environment, like our skin is getting from the sunlight and natural light that we're being exposed to out here, that's a very confusing signal, and the body doesn't know what's happening. And people have talked about a lot about how autoimmunity and all these diseases like that, they start in the gut. There's this gut associated lymphatic tissue, and all these types of things. And it's like, well, potentially it could be because we're getting very confusing signals based on our external environment and the internal environment from the food that's being the signal of food is being projected onto our gut. Not to mention the fact that our external environments are filled with artificial light and things like that, which could just be even more confusing. So if I would wonder how much of that plays a role, and how it's just the body's doing exactly what it's supposed to do given the signals that it's getting. If we change the signals and make them more coherent or cohesive to our external environment, we may get a different result.
Given what we've just shared, somebody up north in Canada like myself, are there any plants in the wintertime? I can think of things like kale, you might be able to grow that. Arguably not a healthy food anyways, for other reasons. But somebody up in Ontario, what do we do in the winter? Obviously the obvious is to go carnivore, but are there any plants you can think of that would be helpful during that time?
Yeah, well, I don't know, because I don't know exactly what grows up there. And I don't even know exactly what plants would grow in my environment. I just go carnivore in the winter because that just makes the most sense. But I think that one thing is we have to put this in the context of what it was like for humans in the winter in Ontario, right? You probably weren't eating every day. You were hunting when you could, and maybe coming across some plant foods you could nibble on, but it was pretty scarce. And generally, that's what winter is really supposed to be about. We have lives now where we can't kind of hunker down and take it easy. But if you think about it, trees die in winter, bears hibernate. It's just supposed to be this time of more rest and relaxation. We get more darkness hours, which means more melatonin, which means we're supposed to be getting a signal to sleep more and kind of rest. And we don't do that. So we likely wouldn't have needed that much food, or as much food as we do in the summer when we're more active and everything. So that's probably not helpful for the modern day person that just has to do things. But I guess the closest thing you could get is just stick to more animal foods in winter, and try and rest and sleep as much as you can, like more in the winter. That would be more appropriate, I would say.
As we continue to build upon this puzzle, bringing in, we've already done diet, but sunlight and grounding, we can quickly see how somebody who wants to be preventative or has a chronic disease living down south in a tropical area is just so much easier and more advantageous on all those fronts.
Yeah, I mean, it's like what everybody does in the winter. They go vacation at the beach or down in the tropics, if they can. It's like the place that choose they go, because you're able to, again, get outside in sunlight, put your feet directly on the earth. More whole plant foods are available there. So you can eat more whole plant foods there. Whereas if you're stuck up here in the winter, really what's technically available to us is animal foods. So it's attractive, right? And the first thing you do when you get to the beach, most people anyways, is take their shoes off. And maybe that's because the sand feels good. Maybe it's because they just know this is, and like inherently, this is better for me. This is a better environment. And we kind of seek it out.
When it comes to deuterium in the body, how long does it stay in the body? And is there a way to detox or get it out of the body quicker?
That I don't know, but I think that one potential way is mitophagy. So if you get a bunch of mitochondria that are clogged up with deuterium, one way that you can help purge that is mitophagy, killing off old mitochondria so your body makes new healthy ones. And that process is stimulated by a lot of things that we see in winter, actually. So maybe some fasting, maybe some lower carb diets like ketosis, maybe some cold exposure, different things like that. I think there's, again, no coincidence that those are things we have naturally been exposed to in winter that also induce this autophagy, mitophagy that happens with those things that, again, we're supposed to be doing in winter, resting and restoring and rejuvenating. So yeah, more sleep, more optimized sleep, higher melatonin levels because of more darkness signals. All those things would be useful for those types of things, and that's what's supposed to happen.
Talk more about the fasting piece and how you incorporate that, because I know for you, you like to eat within 30 minutes to an hour when you wake up with a protein bolus. Is that through the winter as well? And in the winter time, are you doing any longer fasts?
I have in the past. I didn't this winter, and I typically don't do any more than 3 days. And I'm of the opinion that unless you're like really metabolically unhealthy, really overweight, that kind of thing, that longer fast may not be that beneficial for you, or at least as beneficial it is for those people that really need to heal. And I think that, Jason Fung has done great work with that for those people. But generally, yeah, up to 3 days. And then on my daily routine, I'm definitely more intermittent fasting. But like you said, yes, I do think it's very important to eat in the earlier window of the day, especially in the winter. We want to generally eat when the sun is out, because we are designed to digest when cortisol is highest. And that's when we're getting a bright light signal, blue light signal from the sun. That's when the cortisol is highest and we're designed to digest. So if you eat too close to bedtime, when your body's trying to get into melatonin mode and decrease the cortisol, it can be disruptive to what's supposed to happen when we sleep, which is deep restorative healing sleep, and not like, cleaning house and instead of digesting. And it can also create or keep cortisol around a little too much because your body's trying to digest, and that can disrupt your sleep. Because if cortisol is too high, and then you're going to wake up in the middle of the night and things like that. So that's just one thing that can contribute to cortisol being too high. But yeah, so it's really important. And, setting your circadian rhythm, especially getting like UVA light in midday, is really useful for pain, because it stimulates, I think it's alpha MSH, which is going to increase or decrease the sensitivity to pain. So basically, it decreases the threshold for which your body responds to that chemical change in the tissue that's happening. That chemical change could be more and more and more, and you're not responding to it. It's going to increase the threshold at which that would happen. So all that stuff, super important.
Okay, let's connect what you just said to serotonin and then melatonin at night.
Yeah. So ideally, we're seeing sunlight throughout the day. Obviously, that's not realistic for most people. So we want to go outside at least 5 minutes at a time, maybe 4 or 5 times a day, and get sunlight. This is especially important at mid morning, which is when UVA light first comes from the sun as it gets to the certain angle. I believe it's 10 degrees above the horizon, and you're going to get UVA light. And that signaling from light from UVA tells your body to do lots of different things. One of them is to make serotonin, which is like the feel-good hormone, makes us feel better about life. But how much serotonin you make when you get UVA light in mid-morning is going to dictate how much melatonin you can make later. When you block blue light after sunset, ideally, we're blocking blue light after sunset. So the storage of serotonin, that's going to be converted to melatonin later. So how much serotonin you have will dictate how much you can convert to melatonin. So I tell people, like, your good night's sleep starts with UVA rise in mid-morning so that you can get the melatonin. And the melatonin, again, is going to help you signal to go to sleep, but then have deep healing sleep as well, which is when the repair happens, when the rejuvenation happens. So, yeah.
Obviously, there's a lot of variables depending on where somebody lives, time of year, but what would be the optimal dose of that UVA light to get the most serotonin, to get the most melatonin later?
Well, again, we're supposed to live outside, so it would be the entire window, right? That would be the optimal amount. But I would say at a bare minimum, 5 minutes, at least give your body the signal that UVA has happened. And I mean, I don't always get out there exactly when UVA rise is. Maybe I'll get out there an hour after it, but I try and get it with the window before UVB happens, but I try and get there right at UVA. And it's just going to change throughout the year. It's not always going to be the same time. So, there's apps you can get on your phone, like My Circadian, that will help you track that stuff, and when sunrise is, because that's going to change when UVA is, when UVB is, so you can try and time it to get out there and do that.
For somebody relying on getting light through windows, talk about the difference in quality between that and being outside.
There's a few. One of them is that the windows let in more blue light. So it's almost kind of like having a blue light bulb. Not as bad, but it's still leaning that direction. So we have to think about this as processed light. So it's the same as processed food. When you take a whole food and you concentrate it down to one of its constituents, then it's processed. And we're getting a much higher amount of that without the context of the other nutrients in the food or the other compounds in the food. Same with light. If we have all these different colors and wavelengths of light, and we process it down to one, or primarily one, which is like an LED bulb, very high in blue light and very low in the other colors, that's processed light. And so if you filter out, like the windows filter out light, some wavelengths of light from the sun, we're getting more processed light because we're getting higher amounts of, say, blue light's coming more through the windows. But also the windows, modern windows, the double pane windows, they're filtering out UVB. And so there's actually some studies that show that, exposure to too much UVA without UVB, it causes the changes in skin cells that lead to skin cancer. And I talk about those studies, that study in the book. So it's really about, like, people talk about skin cancer all the time, and it's just like, do you realize that the studies that show that UVB light causes skin cancer were done on genetically bred mouse that were hairless? And so A, they don't have their hair to protect their skin. That's not normal. And B, they use just UVB light lamps, which UVB never comes on its own. It always comes balanced with all the other colors and wavelengths of light. So that's a totally unnatural experiment. And that's what we're using to say that UVB causes skin cancer. As a matter of fact, you look at studies, and these are just associational studies, but the associational studies show that the people who get more natural sunlight have less skin cancer than the people who don't. And the people who work outdoors get less skin cancer than people who work indoors under artificial light. So huge discrepancies there, and kind of myths about skin cancer. But yeah, one of them is modern windows. They're filtering out wavelengths of light that would make it more balanced. And then people say to me, well, that would mean that an infrared sauna is processed light, and a red light panel is processed light. And you're absolutely right. It's processed light. The reason that these therapies seem so beneficial, or they are beneficial, is because we're so deficient in red and infrared light. So UVB and blue light, that's there's less of that throughout the day. Like the amount of UVB is 0 at sunrise, and blue light spikes, but blue light is only highest at solar noon. So the amount of blue light varies throughout the day, but the red and infrared light is steady all day long. 40 to 50% of the sun's rays are always red and infrared. And if you work indoors and live indoors, you're getting none of that. And it's supposed to be a constant stimulus. So we use these red light panels, we use an infrared sauna. It seems very therapeutic and beneficial. However, if we use them too much, they would become damaging, right? If we sat in front of a red light all day long, it would be like sitting in front of a processed blue light all day long. I think that it would have a negative effect. And if you look at the studies on red light lasers, like low level light therapy, there's a threshold. Like it's a bell curve. It goes up like this. It's beneficial, and then it's not beneficial anymore if you use it too much. And that's exactly what we would see. But it's just hard to overuse those devices because we're so deficient in red and infrared light.
There are different variables, again, like where you're living, time of year, time of day. But talk about exposing ourselves to light in a healthy way. And you've touched on this. I want to make sure we went there. People that are fearing getting outside and getting sunlight because of things like skin cancer or skin damage. But talk about building a solar callus.
Yeah.
And doing this in a healthy way where we're going to get the benefits from that light.
Most people, they wait till it's warm enough and it's the right season. And even then they don't go out at sunrise. They don't go out at UVA light, and they say, wait till it's midday, and they haven't been out all season. It's the first warm day of the year. They go outside, boom, you burn. Of course you're going to burn, right? You haven't given your body any signals to prepare for that more intense light. So the syncing your body to the day-night cycle and exposing your body to sunrise and then mid-morning sun and then midday sun, and doing that day after day is helpful. But then doing that throughout the seasons is also helpful, because you're telling your body, hey, prepare for the more intense sun of summer. Oh, now it's going away. We're going back into winter. There's supposed to be more darkness. We're healing and repairing. Oh, now prepare for that more intense sun of summer again. Like if you don't give your body those signals, it's going to be like freaking out when you go out into midday sun in the middle of the summer and you burn. Right. So I am super pale, or I should be. I am, Irish heritage. And if I don't get sunlight, I'm very, very pale. But I never wear sunscreen. I go out and I set my circadian rhythm. I'm very in touch with the day-night cycle. I've been doing this for 3-4 years now, and I don't burn. I can be out there for a very long time. And even if I do get a little red, it doesn't peel. It doesn't it goes right into tan. And I can't say I'm like the most tan person. I just have genetically less melanin than some people, but I don't burn. And so that's how you have to kind of set this solar callus. And as you're doing that, and it does take consistency. You have to be able to do it day in and day out for it to happen. But as you're doing that, be smart. Don't burn if you know you're going to burn. Like work up to that solar callus. Build yourself up to it, and then. Sunscreens are pretty toxic, and they also block UV light, which makes for imbalanced processed light coming from the sun now, because we're blocking one wavelength and letting others in. And so that's not ideal. So we would want to cover up with clothes, like light clothing or hats or things like that. Just be smart about it. But this is more of an opinion, just stating that from the get-go. But I don't think getting sunburn is what's causing skin cancer. I just don't that doesn't make sense. It'd be like, yes, it causes skin damage, but is that going to result in skin cancer? I don't think so, because we don't say that cutting our skin and causing damage to our skin that way is going to cause skin cancer. It doesn't make sense to me that it would. So I think the signal of cancer is happening because of imbalanced light signals, because of our artificial light environments and modern windows and using sunscreens. We're creating these imbalanced light signals when it comes to UV versus blue and all this kind of stuff. That's the real problem.
You quickly mentioned melanin. This is something I want to get into with you. Talk about what that is and how this can be another strategy to make energy in the body.
Yeah, melanin is Well, I mean, it's most famously known for what gives our skin our pigment. So, people of Caucasian descent have much less melanin. People of African American descent, and the Pacific Islanders, all of them, they have much more melanin in their skin. That's what gives them a darker skin. But I can increase the amount of melanin that my skin produces by getting more sun. But melanin, people think that's just what it does. It gives your skin pigment, but it actually does a lot more. And if you look at nature, melanin is concentrated everywhere. It's in all these animals. It's on the bark of trees. It's all over the place because melanin has these very awesome properties in which it can take light energy and turn it to mass, right? So light has no mass, and you take light, you turn it to mass, you turn it to electrons. And melanin can do this. But melanin, it's not just light that melanin can do this with. It can do it with so many different forms of energy. It can do it with vibration. It can do it with electromagnetic energy, lots of different forms of energy. But it can harvest that energy or use that energy to dissociate water in the body. And, there's arguments that we're like 99% water if you look at us by volume, right? 99% water molecules. And so we have melanin, and it's not just in the skin. It's concentrated everywhere in the body. We have it in the back of the eye. We have it in the nervous system. It's everywhere. And so when light hits the body, melanin takes that light, uses it to dissociate water. What does that mean? It means it breaks water up temporarily. So it takes two water molecules and it makes two molecular hydrogens. It makes oxygen, and then in the process of doing that, it releases 4 electrons. And so then the electrons are released and the water can become water again. But that's how, light hitting your body, one way that light hitting your body creates electrons, it just makes sense naturally. Like we harvest energy directly from the sun. And that's one way we do it. And so then those electrons can be picked up by the fascia system of the body and literally transferred anywhere they need to be, all the way down to the nucleus of the DNA if need be. But they can go right into the cells, right into the mitochondria, and they can be used. So it's a very important role of melanin to be able to do that.
Similar to melanin, DHA, and this is something we can more control by our diet. That gets incorporated in cell membranes, and we can make energy when sunlight interacts with that. Bring that piece in.
Yeah, so DHA is an omega-3 fatty acid that we all know. People take their fish oil supplements and things like that, which I don't necessarily recommend, but we get it from animal foods. We get this omega-3 fatty acids from animal foods, and DHA has what's called a pi electron cloud around it. So it has this concentration of electrons around it, and when light hits that electron cloud, it excites it, and it literally creates DC electricity from that. This is what Einstein described as the photoelectric effect. So again, light hitting something, making electricity. And that's what DHA does for us, which is why it's concentrated in high amounts in skin. It's also why, when you look at red blood cell membranes, they have lots of DHA, and that's why when we get out in the sun, we turn a little bit red and pink, because the blood is rising to the surface of our skin to soak up more sunlight and use that to create electrons. And so that's exactly what's happening. And when we use plant fats instead of animal fats, we start to build our tissues and red blood cells with phytosterol. Then that's a problem. And there's studies that show that building and I talk about this in my heart book, that when you build red blood cells, the cell membranes of red blood cells with plant sterols, phytosterol, then they become more rigid. They're not flexible, which can damage things when they get into tight capillaries and things like that. But it also interferes with the ability of your body to harvest electrons from sunlight, or turn sunlight to electrons. Because the red blood cells come to the surface and they're just full of plant sterols, and they can't have that photoelectric effect from the pi electron cloud. So animal foods is one reason why animal foods are super important, and why historically humans have eaten a lot of seafood, because it's very high in DHA. So, yeah.
Let's talk more about phytosterols. So this will pivot off of something we talked about earlier. Being down south, say somebody's down there and they're in the, we'll just say summer, taking in more plants, but now we have this phytosterol piece and taking in these fats that are going to get incorporated in red blood cells. We've omitted the other arguments we brought up before, but now we have the phytosterol piece. So what I'm getting at, I'm trying to parse this one piece out. Somebody who is, say, in Florida in the summer, eating plants, incorporating these phytosterols, are they still better off eating animal foods because of this DHA piece?
I would say so, yes. Which is why even if you look at like Weston Price's travels and things like that, and how he went around the world, they were all prioritized these animal foods. They all prioritized getting butter from a cow if they lived in the Swiss Alps, or if they were, on the coast, they were eating tons of fish and fermented fish and things like that. Like they were prioritizing animal foods for a reason. And Weston Price said, he conjectured that it was the vitamin K. That was one thing that they were really getting from the animal foods, and that is one thing they were getting. But it's also because they were optimizing their ability to harvest electrons by sunlight. And maybe they understood that, maybe they didn't. I don't know. But it was critically important. But that doesn't mean that you can't eat plant foods. It just means that you need to make sure you're getting enough animal foods so that you can harvest energy in different ways. Because if you don't, like, there are scientists out there that say that we should get only a third of our energy from food, from actual metabolism, or metabolism from food, because I consider metabolism harvesting electrons from anywhere and using it to create ATP and structured water in the body. And so if you interfere with that, then your ability to harvest those electrons, you're making yourself really dependent on just food. And that's a problem because then we're overworking our metabolism as far as glycolysis and Krebs cycle, instead of just getting these free electrons from the environment. It's requiring a lot more work to get those rather than just changing it from light energy or directly from the earth, grounding and bringing those electrons directly in. So it's a reason we're supposed to live outside, and it's a reason that when we live more inside, we are starting to see these diseases, especially these metabolic diseases that we're seeing, these breakdowns in mitochondrial function. Yeah.
Given what you just shared, a third of our electrons roughly coming from food. The other two big ones are grounding and sunlight. Theoretically, do you feel like somebody could go without food if they're living in the tropics, getting that sun and grounding and just getting their electrons from those other two pieces?
I don't know. I don't know if anybody's looked at that or studied that. I mean, we definitely have people who claim to be breatharians.
Which is what I'm getting at.
Yeah. So it'd be interesting. I've never met one, never talked to one, so I don't know. But I guess that scientist that I'm talking about, he's saying that we're supposed to get a third of electrons from food. So we still need some from food, I guess he's saying. But I think more importantly, because there's people that talk about macros as far as energy, proteins, fats, carbs, things like that. I think it's much more important to focus on nutrient content. Is the food providing you with adequate nutrients? Does it have the nutrients in there that you need, and are they bioavailable to you, which is a very important piece? Can our digestion actually absorb them the way it's supposed to? And then, the energy piece will, especially if we're in the right environments, more sunlight, more grounding, then the energy piece is less important. As far as, because your body will take what it needs from that food, the energy it needs, and the rest it'll get from its environment if you're providing that to it. So that's tough in the modern world. I have to spend 28, 30 hours a week in a clinic that's indoors under artificial light. But when I'm not in that clinic, I am outside as much as possible. And even then, like, I have a window open right now, just trying to get natural light in. It's not being in direct sunlight, but it's trying to get natural light. So just doing all those types of things as much as you can is really important. Yeah.
Shortly before we jumped on here together, I saw on your Instagram stories you're out getting sun, shirt off, which brings me to the benefits of sunlight on the skin versus the eyes.
Well, for a circadian rhythm perspective, the eyes are more important, definitely. But sunlight signaling on the skin is also, it plays a role in circadian rhythm as well. But then the benefits of sunlight on the skin is all the electron harvesting effects that you're getting. Plus, like there's things like if you UVA light or UV light in general, actually, on the skin has been shown to produce heparan sulfate in the skin, which is a potent anticoagulant. So we talk about these coagulation diseases, atherosclerosis, heart attacks, strokes, people getting DVTs and just random clotting. Like UV light is very important. I mean, when you go and you have a clotting disorder or clotting issue in the hospital, they administer heparin. Like that's what they're trying to do. They're trying to break up this clotting material. And so that's just, I mean, there's probably 1,000 others benefits of getting natural sunlight. But from a circadian perspective, the eyes are more important. And so that's why blue blocking glasses work so well, because you're protecting the eyes as long as you're looking straight forward like not looking out the side of the glasses, but you're looking straight forward because that's where the light comes in through the pupils. But there are benefits to getting sunlight in your eyes as well. Getting red and infrared light through your eyes is definitely helpful for the arteries in the eyes, health of the arteries in the eyes. I don't know the specifics, but I just remember reading a post from an optometrist talking about UV and the benefits of getting UV in your eyes, and she was listing out all the benefits there. So natural light, full spectrum light, very, very helpful for the eyes too. But from a circadian perspective, the eyes are more important than the skin, even though they both play a role.
I see these people on social media sometimes talking about getting light where the sun don't shine, genitals, but how do you feel about that? Have you looked into any research and actual benefits there?
I haven't, but given the effects of sunlight and signaling on hormones, I would say that there's probably benefit. However, I don't know if I don't want to say necessary. It's definitely not realistic for the average person, I would say. And whether or not that's going to move the needle in society, that's what I focus on, right? What's going to be the most impactful? What are the most people going to do? People who are out there who want to optimize their health, biohackers, whatever, if they want to do that, fine. I haven't looked at any specific research to say, yes, it's doing something, no, it's not. But again, I'm more focused on the things that people can actually do and are actually going to do and move the needle a bit more in society so we can move more toward this healthy world.
All right, let's come back to DHA. Mm-hmm. And you quickly mentioned you wouldn't necessarily recommend supplementing with that. Talk about the details there. And then how much DHA, given what you explained before, is ideal?
I don't necessarily have a set amount, but I think that if you are prioritizing protein in your diet, preferably like good, healthy animal-based or like animal protein that's grass-fed and naturally raised, as much as you can get that, then the better it's going to be. I think that studies show that like the nutrient content of grass-fed versus conventionally raised, like industrial raised, is not that different, but there is a slight difference in omega-3 content of the grass-fed meat. It's much higher. So if you're prioritizing protein, you're getting enough protein a day, and that's animal fat protein, then you're getting enough DHA, I would say. Now, as far as supplement goes, people want to supplement a lot. There's all this literature that shows that it's anti-inflammatory, it's good for heart health and all these things. However, I think that the bigger issue, so you want like your omega-6 to omega-3 ratio to be 1-to-1, at the worst 3-to-1. And people today are like 30-to-1, because of all the seed oils and the omega-6s we find in those seed oils, or just other, I guess, plant fats or foods heavy with plant fats in them, even like a grain, so to speak. But we're getting way too many omega-6s. And so people are like, oh man, we got to make the ratio 1-to-1. So we got to get the omega-3s up. You got to take your omega-3s. Like, no, actually, we should just decrease the omega-6s and bring that ratio down. And then the problem I found with taking omega-3 supplements is that they're unsaturated fatty acids by nature. Omega-3, like the third carbon on the chain, is unsaturated. And so they're prone to oxidation when they're unsaturated. Whereas saturated fats all the carbons are saturated with hydrogens, they're much more stable. They're not going to get kinks in them and get damaged. So when you take that omega-3 out of the fish, it's very hard to keep that stable. It's very prone to oxidation from light, from heat, from all kinds of stuff. And so if you want to avoid those, then I would not take omega-3s. And like I said, it's very hard to make them stable. Some people would claim that if you ferment them, then they're more stable, and that may be, but I would just rather eat it in a whole food because it's still packaged in the tissue, and I'm going to consume it in the tissue.
How do you feel about vitamin D? We now know that potentially a third of our energy can come from the sun. Vitamin D in our world is one of the most common supplements people are talking about. It's obviously challenging for people like us that are more north in the wintertime. So talk about all those different aspects and how you look at that supplement.
I don't think in many cases we should never treat blood work rather than a person. So if someone gets their blood work done and it says low vitamin D, I have no idea if what we chose to be low vitamin D is actually low vitamin D. And I can admit that, even being a practitioner studying this stuff, I don't know what low vitamin D is. Well, I do know it's when you get low vitamin D symptoms. Do you have rickets? You probably have low vitamin D, that's an indication. So in the absence of symptoms of low vitamin D, I'm not going to treat the vitamin D. Plus the other aspect of this is that I would be very, cautious about taking hormone replacement therapy. And vitamin D is a hormone. It's kind of mislabeled as a vitamin, but it's a hormone. And if you're taking high amounts of a hormone, then you're telling your body not to make that hormone. And what is that signaling to your body? Well, the process of making those hormones is almost just as important as the hormone itself, because there's intermediate products that are made in the process of making that hormone that are used by the body for other things that are important. And if you just give your body the hormone, it stops making it. So yes, you take vitamin D, it has a very anti-inflammatory effect, but it doesn't really, for most people or lots of people, I would say, it doesn't really raise your vitamin D levels because it's acting like a steroid. It's a steroid hormone. And so you're taking a steroid and you're having anti-inflammatory effects, but it's not really making your body make more of it. It's telling it not to make more of it, actually. The other aspect of this is people will say, well, yeah, but in winter, we don't get enough vitamin D. It's like, of course we don't. Nature's not giving us the signal to make vitamin D. So why would we want to make more of it? Nature's not giving us UVB light. And so this is mostly because vitamin D and melatonin have been shown to do the same things in the body, many of the same things. I won't say the exact same thing, but many of the same things. Because in the summer, we're supposed to have, depending on where you live, you're supposed to have more sunlight hours, more UVB hours, more time outside. You should be outside more, making more vitamin D. In the winter, we're supposed to have more darkness hours, which darkness or lack of blue light signals for melatonin production. So they're supposed to switch, right? The problem in winter is not that we have low vitamin D. Nature's not giving us a signal to do that. It's we have low melatonin because artificial light is completely shutting down melatonin production. We're supposed to make that for longer periods because there's more dark hours. That's what's supposed to be happening. So if you are worried about your vitamin D in the winter, don't. Start making more melatonin. Block blue light. Be conscious of your light environment after sunset. And it's the same with melatonin. People say, well, can I just take melatonin? It's like, no, when you take it, you tell your body not to make it. And again, the process of making it is just as important as the hormone itself. It's the same with cholesterol. Like, the process of making cholesterol is very important because there's like 20 or more steps to making cholesterol. And those intermediate molecules are used for various things, which is why when you inhibit the step at step 2 or 4, or whatever it is, HMG-CoA to mevalonate, like when you inhibit that, then all the other byproducts or the intermediate steps don't get made. And those things are used for many other things, which is why you have all these different side effects with statin drugs. So we have to be careful about interfering with the body's natural processes because it's all used for something. And so that's kind of my spiel on vitamin D.
What about other supplements? Are there any that you take?
No, I'm not huge on many supplements. I take electrolytes. I think that's super important. And right now I'm taking nattokinase. I don't really have necessarily any reason to. But the reason I started taking it, because I took serapeptase, if people listen to our first podcast, they hear about my story. I took that initially when I reversed the plaque in my leg. And then between the last podcast and this one, I actually went and I got a CT angiogram of my coronary arteries, and I got that analyzed by Clearly, and my arteries are fairly clean. That have a very small amount of plaque in their RCA, the right coronary artery, which they detected was there when I had the heart attack. When they went into the angiogram there, they said it was there, so it hasn't progressed. It's generally about the same amount. But I'm like, hey, let's see if I can get rid of that. So I started taking nattokinase again. Otherwise, my arteries are completely clean. LADs completely clean, everything. So, and then I'm also taking some phosphatidylcholine right now because someone approached me and wanted me to try the product, and they sent me some. So I'm like, yeah, I'll try it out. There's supposed to be some benefits to the endothelial health. So just trying that out.
Given everything we've shared early on in the conversation about having a diet specific to your location, time of year, how does your diet look in the winter? To me, it sounds like it would be carnivore-ish. And then how does that change in the summer?
Yeah. So for me, it's pretty carnivore in the winter. And then I'll really only start eating some plant foods in the farmer's market, which for me is in May. And even then the vegetables aren't like abundant at that time yet. And I'll eat some low carb vegetables, and I stay low carb because it's just better for type 1 diabetes. It's just easier for me to maintain that. But I wouldn't have any problem with people eating local fruits or higher carb vegetables, as long as they're whole foods. And, diets can be different for everybody. But that's just kind of what mine looks like. And then in the fall, the plant foods I eat will slowly start to dwindle. We'll go back to carnivore, but my diet's always really centered around animal foods, as the priority, and prioritizing that protein. But, people have to find the diet that works for them. I can give you all these principles and ideas about what I think would be best historically and just scientifically or whatever. But you got to find a diet that works for you that you can do and stick to. And, one of my favorite, it was just a friend of mine. I don't know if he made this up or if he got it from somewhere else, but it was like the diet that heals you may not be the diet that's best for you the rest of your life. So have the wisdom to change if you find out the diet's not working for you anymore, and try different things. But generally, always stick to whole foods. Stop convincing yourself that any processed food or processed product, even like health food products, that are generally, more healthy ingredients, if they're processed foods, they're not going to be the same as the whole foods. So, yeah.
How do you look at ketosis for yourself and for others?
I don't really measure ketones in myself anymore. I used to, and I got just a pretty good idea of what I'm going to be, so I just stopped measuring. The strips are expensive, but yeah, like ketosis, I don't think that true ketosis is really necessary. Like, or a true ketogenic diet is really necessary for everybody. I think that people with, certain conditions like epilepsy or things like that, it's like a miracle for them, and they should definitely do that because it has such a profound effect. But I don't think that the goal should be to be in ketosis for the most people. The goal should be metabolic health. And to me, metabolic health is the ability from a substrate, like kind of food metabolism standpoint. The goal of metabolic health should be to be able to have some carbohydrates, a decent amount of carbohydrates, and burn through those carbohydrates and immediately return to making ketones and burning fatty acids again. If you can't do that, you're not metabolically healthy. So a way to test that is, again, I say that eating earlier in the day is better. So stop eating 4 to 5 hours before bedtime. And if you stop eating then, you should, even if you have 100, 200 grams of carbohydrate, let's say in a meal at that point, and you stopped eating them, if you woke up in the morning and you tested your ketones and there was any ketones present, then your body burned through those carbohydrates and then it started making ketones again. And that's metabolic health. So yeah, if you started eating so many carbohydrates that you broke that mechanism and you're waking up and there's no ketones present, you've reached some state of poor metabolic health and you need to, fix that. But I think that also is dictated by circadian rhythm. It's not just the food you eat. But that's a good indication that you're metabolically healthy, is the ability to switch back and forth quite easily. Because we all know about the keto flu, right? You go on this low carb diet and you feel terrible. Why? Because your body's forgotten how to make ketones and burn fatty acids as efficiently as it could. Therefore, when you restrict its food source, which is glucose, it's like, what are you doing? And you feel bad because it's having to, upregulate these mechanisms. And so, we just don't want to get into that state and have to go through that keto flu or that adaptation process. We want to maintain that metabolic flexibility.
Last time we talked, you had gone from a period where you didn't really prioritize hydration to including more hydration throughout your routine. Talk about how you're looking at hydration and the different drinks you're having on a regular basis.
I only drink water, and I have electrolytes with maybe 4 measuring cups of water a day. I'll have like a concentrated amount of electrolytes in that. But hydration I see as, well, cellular hydration is very different than, I'd say, vascular or lymphatic hydration, or like tubes in the body hydration. So I think that vascular hydration comes from the water that we drink, because you're absorbing that water through the stomach, through the intestines, directly into the bloodstream. So it's going right in there. And that's what's going to create the hydration there. So my mistake at that time when I had the heart attack was that I was not drinking enough water. I was drinking maybe a cup of bone broth a day. And so I think that that's very important. Now, when it comes to hydrating cells, the mitochondria are what hydrate cells. And so if we have poor metabolic health, which at that time I could have had some poor metabolic health, my circadian rhythm was very off at that point. Looking back, diet-wise, things were fine. I'd always been eating this low-carb diet, animal foods, but like I said, I don't think that is what drives good metabolic health completely. The embers could still be burning, so I think there could have been some metabolic dysfunction then. But yeah, everybody talks about mitochondria makes ATP. That's its job. I don't think that's its job. I mean, that's one thing that it does, but it also creates heat, infrared light. It creates reactive oxygen species, which are signaling molecules, and it creates metabolic water. And we learn about that in cellular physiology as some byproduct. Oh yeah, it just makes water as a byproduct. It's like, well, what if that's the most important thing that it makes? Because that water is what hydrates your cells, and it's what becomes the structured water gel that surrounds all the cytoskeleton of the cell. So that's what hydration is like. It's metabolic health, and it's drinking enough water. So I would say, I don't know, like 8 measuring cups of water a day at least, and it needs to have minerals with it. Very, very important. So it needs to be free of toxins, full of minerals. And then I like to energize my water in some way to give it a little bit more coherence, so that the water molecules are interacting with each other a little bit better, so that when it gets into the body, it will structure itself better. Doing that, which again makes sense. That's what nature does to water. It's full of minerals. It's always moving it. It's always in sunlight, in contact with the earth. That's where water is.
When it comes to minerals, is there a certain brand you're using?
I use Redmond Relight, but B minerals is pretty good, and I say Quinton minerals. Some people say Quinton minerals. I don't know, but yeah, there's some good ones out there, but I use Redmond Relight.
When you were talking about your water, you gave a little spin there, and last time we talked about structuring a water, which isn't the same as structured water that I want to get more into here. But is there a certain device you use when you're at home to vortex your water?
I just use the analemma wand, and I just, stir that around. It's creating a vortex when you vortex water, which is what happens into water in nature. It's flowing over things, it's going past rocks, it's vortexing, it's creating this turbulence. That's what the heart is. We talked about that last time. But yeah, so that's what I do. But you could also put it in the sun, or somehow put it in contact with the earth without creating dirty water. I know people that have like these little discs that mimic the electromagnetic field of the earth, and they put their water on that. There's ways to energize it. But again, you're just putting it more back in contact with what it would be in nature. Because when it's running through tubes and being recycled through municipal water plants all the time, it's just dead. It's got all these toxins in it. It's being moved through laminar tubes rather than being swished around. It's not in sunlight, so it's just kind of dead water. So you have to do something to it to make it more live water.
Let's talk more about structured water. You talked about the ATP piece and how that's not doing what most people are saying it's doing. Bring that in, and then bring the structured water piece in, and then we're going to tie this into the sunlight and then get into the grounding.
Yeah. Like I said, we all learn in school that we're harvesting this energy from the chemical bonds of food, and we extract electrons from that. And then we use those electrons to pass down this electron transport chain. And during that process, we get hydrogen ions that produced. They go up to the inner mitochondrial membrane space. We get water produced. We get heat, infrared light. We get reactive oxygen species, and we also get ATP. We get all these different things produced as these electrons are passed down these proteins. And ATP holds it's a storage form of energy. So it holds this chemical energy in there. And so that storage form of energy, people think, oh, that must be the energy currency of the cell. It's what supplies all the energy for the cell. However, Gilbert Ling is a scientist that worked a lot with water. His work is actually what led to the development of MRI machines and how you can rearrange the water molecules and get a picture like it can using a magnetic field. And but anyways, he also showed in his work that the amount of ATP that could be produced by mitochondria in a cell, any given cell, there's no way it could produce enough ATP to power everything that needs to be powered in the cell. He said that it couldn't even produce enough to power the sodium potassium pump, if that exists, which I'm not sure that it does. But he did mathematically and experimentally prove this, that there's no way you can make enough ATP to do that. So ATP, it turns out one thing that it does do is it does hold an energy bond. And that energy bond is used to unfold proteins in the cell. Because you get a protein, it's like, if it's all folded up on itself, it's kind of like a tinfoil that's balled up into a ball, right? And so there's very little surface area when it's balled up like that. If you break it open and you unfold it, you get a much more surface area of tinfoil. So that's what proteins are like. They're all folded up, and the ATP comes in there and unfolds the proteins and makes them these big things with lots of surface area. Because what do you need to form structured water? You need a hydrophilic surface. And so there are studies that show that water in the cell is no more than 0.5 nanometers away from any biological surface, or it should be if the cell is healthy. And so that's what ATP is doing. It's unfolding proteins. It's unfolding the cytoskeleton of the cell, or the microtubercular lattice, or whatever you want to call it, in the cell, creating surface area so that the metabolic water that's created by the mitochondria can go onto there and have a surface area to form structured water. Because the structured water is what holds the body's charge, because it's electronegatively charged. And Dr. Pollack has shown that many times in many studies that he's published, and many other authors aside from him have as well. And so that's what holds the voltage of the cell. We all know that, well, anybody who studied cellular physiology knows that the cell holds this voltage, this negative charge, so to speak, this pH of like 7.4 or something like that, slightly alkaline. It's like alkaline means more negative charge, not acidic or positive. And that's what does it. But we have to have this process happening. So ATP is still critically important, because without it, you don't get unfolded proteins. If you don't get unfolded proteins, you get less structured water, you get less cell voltage. And less cell voltage has been shown to be pathology. Cells that are diseased have lower cell voltage than they should. And that's the role of ATP, is to do that as a primary role.
In the three primary ways, I should say, of making ATP, the food, the sunlight, and the grounding, any other big ones that contribute?
Those are the big ones that help produce the ATP. But again, like, the ATP is not the energy storage form. The energy storage form is structured water, and ATP plays a role in that.
No, that's what I'm getting at. To open up the proteins.
Yeah. So yeah, and like And all we're trying to do, like you said, is harvest that energy in the form of electrons from our environment. We can do that for way more than just food. So those things, like you mentioned, are the primary way we get electrons. But we also want to remove the things that interfere with them, interfere with the body's ability to harvest and hold on to those electrons. So things that have been shown, things that have directly been shown to break down structured water in experiments published by Dr. Joe Pollack are wireless signals. So specifically a wireless router is what they used in his study. And it broke down structured water, I think, 10 to 15%, or interfered with the ability to form. And then the other one they tested was glyphosate, which is the herbicide Roundup. And so while we don't know for sure, there's probably other toxins and things that also do this. But if you think about it, since structured water is so negatively charged and it's holding on, like it's negatively charged because the oxygen is a bigger molecule and it's holding a negative charge, and there's not two hydrogens to balance it out anymore. There's only one. So that's what gives it the negative charge, but it's also negatively charged because it's a storage form of electrons. Because the water molecules are now kind of linked together, kind of like an ice, but without the extra hydrogen, electrons can travel through them, right? So electrons are traveling through it, and that's what gives it this negative charge. That's why it's a storage form of it. And so if you interfere with that, you bring down the body's negative charge. But since it has this negative charge, we all have heard that, oxidative stress or inflammation or things like that, those things steal electrons from the body. And the place that it would steal electrons would be structured water, because that's where the electrons are stored. And so that makes sense that when you look at what glyphosate is and how it acts like one thing that can cause, inflammation, oxidative stress, this kind of stuff. It's just stealing that charge. So anything we know that acts like oxidative stress, like heavy metals in the body, could act like that. Or when we get poor metabolic health and we're producing too many reactive oxygen species, like all that stuff could contribute to this destruction of structured water and then low voltage in a cell. And that's just well-known science. The oxidative stress breaks down or steals electrons from tissues, and it steals it from structured water. So then, wireless router and toxins. So we want to remove the things that steal the charge. We need the raw material, which is water, which we make from mitochondria or we're drinking for our bloodstream and lymphatic system and stuff. We need to expose ourselves to the things that build structured water. Infrared light mainly, but sunlight is the original form, and grounding, and then healthy metabolism. So we're extracting electrons from that, and then we remove the things that break it down. And if you look at that recipe, it's like, and look at the modern way of life, it's a bad recipe, right? That's exactly what we're doing, where we create poor metabolic health. We're not drinking enough water. We're drinking these dehydrating things, a bunch of caffeine and sodas and things like that. We're not living outside with feet contact with the earth in sunlight, and we're surrounded by artificial blue light and EMFs and exposed to so many toxins. And it's just like, no wonder our bodies are struggling. That's and so when you talk about pain, like that's going to significantly increase the likelihood that cell voltage drops. And what happens when cell voltage drops? It's one thing that your body says, hey, what's wrong with this tissue? I'm going to send a pain signal there. So that threshold of what's going to cause pain is drastically increased.
Let's talk about the next step of this story. So you have your mitochondria making ATP, unfolding proteins, structured water is forming inside the cell. How does that energy then get used?
The cellular energy, like the structured water energy?
We used to think of it as ATP, but now that we're saying the energy is actually the structured water, how is that used by the body? The next step.
Yeah. So this goes down to like phase transitions. Well, first of all, structured water is a battery. So it's when structured water forms, there's an area of negative charge. And then because of the way it forms, it creates an area of positive charge next to it. And that positive next to a negative creates an energy gradient that it stores energy. It basically, just like a battery, stores energy. There's a positive and negative into a battery. We're concentrating energy in that area. And so this is what structured water does. And so when you form structured water on this protein in the cell, you've created a battery right there. And in Dr. Pollack's lab, they've shown that you can plug, like they make a structured water zone and they put an electrode into the structured water and into the positive area next to it in the bulk water, and you can power a light bulb. So you're creating energy, you're creating electricity. And so it's stored right there. So when you think about this, it's not like all the cellular proteins are unfolded and everywhere in the cell is full of structured water. The majority of it is, but not all of it. And so there's still these little pockets of things where there's not structured water, or there's still these little pathways. And we talked about in our last episode how this does the work of moving fluid. This energy gradient does the work of moving fluid, and it's the same thing in the cell. That's what kind of keeps the fluid moving through cellular pathways. And this happens even in embryos where there's no heart function yet. That's how fluid starts moving initially in embryos. So that's what's creating this fluid movement. And then we also get what are called phase transitions. And so Dr. Pollack wrote a very good book, very well cited book called Cells, Gels, and the Engines of Life. And this book basically makes an argument that physiology happens through phase transitions. What I mean by phase transition is, like we talk about structured water, it's actually the fourth phase of water. And so when we talk about a phase transition, it's going from a liquid phase to a structured phase and vice versa. And when that happens, cellular physiology happens. So we start to see action potential. So we learned in school that an action potential is when this depolarization of a cell happens. So depolarization means it loses its charge temporarily. How does it lose its charge? A phase transition. It loses structured water temporarily, and then it comes back, right? And that phase transition, there's many things that can signal a phase transition. It could be a change in pH. It could be a temperature change. It could be anything, all these different things. And it signals for a phase transition. And that tells the cell to do physiology. And the cell that happens here, then it happens to the cell next to it. And it's like this, it just happens super fast. And that's what this depolarization is. And then repolarization of a cell is. That's what we see. So that's how physiology happens. And that's how the body uses that energy to hold the charge and then create phase transitions in response to external stimuli.
Got it. That was what I was getting at. So phase transition is when this structured water is actually used to do something in the body. And that's when it goes from being structured water to a liquid again, and then it goes back.
Mm-hmm. Yeah.
And all that happens, I'm assuming, super quick.
Yeah. Like faster than you could probably think. Like it's so fast. But that's what, like, everybody who studies physiology in school, we study like nerve conduction and action potentials. That's what we're studying. We're saying, oh, this depolarization happens in the cell and then it repolarizes and it happens really quick. And that's what sends a signal down like a nerve or whatever, this action potential. When in reality, it's like a continuous phase transition that's happening, and it's happening instantaneously. Like probably happened 1,000 times in the last sentence I just said. It's how physiology happens. And like, again, Dr. Pollack in his book, he showed how phase transitions are responsible for muscle contraction, nerve signals, and various other things, parts of physiology. That's just the evidence we have so far.
All right, let's move into the third big input, grounding. For yourself, in the wintertime, how are you grounding on a regular basis? I know part of your strategy is this grounding pad in the house, but are you getting outside and grounding as well? Talk about the full strategy there.
Yeah. So I get outside pretty often. I'd probably say 30 minutes to an hour a day of outside grounding in the winter. It's probably more than that in the summer because I'm just outside more. But yeah, then I'm using the indoor grounding sheets and grounding mats and things. And so, but it's important for people to understand that it doesn't have to be directly on the earth. You could be on a patio stone that's directly on the earth. So if it's like, I would say 4 inches or less, patio stone or concrete is also conductive. Asphalt's not very conductive because it's got rubber in it. The bark of a tree is not very conductive, but the leaves are. Mulch is not conductive because it's dead wood. So there's lots of different, but there's other options. Sand is conductive, dirt, grass. But yeah, I mean, the other thing is like you could like plug or like stick a nail, like a big nail from Lowe's into the ground and wrap copper wire around it and bring that in through the window of your house and just close the window on it and hold the wire and you're grounded, or I've had clients that do that and they're sitting there at the computer working and they wrap the copper wire around their leg, and I'm just like, you got to remember this there though when you want to get up. But yeah, there's ways to do that if you're wanting to get more grounding time.
So obviously time's a factor. What about contact with the ground? So if you're exposing more your body in, say, laying in the grass in the summer versus just having your feet there, does that make a difference?
Yeah, I mean, you're going to absorb more. The more like surface area you have in contact with the ground, the more electrons you're going to conduct. But it starts happening instantaneously. So as soon as your feet conduct or touch the earth, you're going to start conducting. So any amount is beneficial, even if it's just 5 seconds, like you soaked up some electrons, right? But yeah, the more surface area, the better.
What about PEMF, especially people like us that are more north, and it's more difficult, especially in the winter, to get outside?
Like a PEMF mat?
To be honest, it's not something I've played with, but I've seen them online where there's these machines and then there's a mat connected to it. You can sit on it, and the way I understand it, you might know better, it's just like grounding on steroids.
I would say that it's more so like it's mimicking grounding in a certain way. No, I don't know. I guess it depends on the PEMF mat, but the PEMF is pulse electromagnetic frequency. So to me, they're mimicking the electromagnetic field of the earth, the Schumann resonance, which you're in contact with more when you're grounded. You're outside directly on the earth. But we're all in the electromagnetic field of the earth right now. We're sitting in it. And the other frequencies, other electromagnetic frequencies, the wireless signals and electromagnetic signals from like electricity coming through the walls and stuff like that, that's affecting our ability to be just like wholly in contact with the Schumann resonance. So PEMF, from my understanding, is more like those electromagnetic frequencies that are more harmonized with the Earth's. So they're giving you more of a stimulus of that. I don't know. I've never heard of a PEMF mat being a grounding mat as well, but they may be. They may have like ones where you can plug right into the wall and into the grounding prong in the wall. But it's more, for me, electromagnetic energy than being conductive electrons from the earth.
When it comes to the structured water piece, creation of energy, does movement fit into this at all? We know that there's the big three, but how does that incorporate if it does?
Yeah, so you can definitely create electrical current by movement. So the fascia in your body is, I kind of thought of it as like a Spider-Man suit, that kind of just holds you on from the outside, but it actually goes everywhere. It penetrates all the way down into the cell, into the nucleus of the cell. And it's what holds everything together. It's kind of like the structural framework for the body. And fascia is very hydrated with structured water. It's a hydrophilic surface, and so water will structure itself on it. And they've actually shown this. Like I forget the guy's name. He's French, but he has this video where he inserts a camera under live tissue, and he starts moving the tissue, and you can see the fascia like changing its connections to other fascia. It's like it's to me, it's like the stairs in Harry Potter where they change like this, and it's like doing that with the fascia as the person's moving. But you can also see the wetness and the hydration of the fascia. So it's has the structured water on it, and we have the literature that shows that there's structured water. But when you have hydrated fascia and you move it, it creates this piezoelectric effect of tissue, which is also very well established in the literature, that you can create this electrical current. I think that the fascia has to be well charged for that to happen. But when you move your body, you're basically you're freeing electrons from fascia and structured water to be pushed elsewhere. So you're basically able to use it. So if you charge up from the earth and you get sunlight and then you move, then you're moving those electrons to places they need to go, like into the cells where they can be used to make ATP and hydrate and things like that. So movement's a very big part of this. And then you get bound up fascia, you get scar tissue, which is very tightly packed fascia together. Structured water can't form on it because it's so tightly packed together. And so breaking up that scar tissue is very helpful, because if it's there, it interferes with this piezoelectric, ability to be sent from fascia somewhere else, or from somewhere to somewhere else.
Got it. So exercise itself isn't creating energy, but it's the fascia in our body that's almost like a storage of that energy through the structured water. When we move, we can release it and use it as needed.
Right. Yeah. So remember, like laws of the universe say energy is not created or destroyed. So we can't create energy from movement, but we can, I say, mobilize energy as long as our body is charged enough. So we have to be in the right environments. And the more we move in the right environments, so I like to work out outside. People see me on Instagram, I'm using my bike in the sun. I'm trying to my Peloton or whatever. Unfortunately, I can't lift weights in the sun. I have to go into a gym, but I'm only in there for like 20 minutes, and I can't justify buying my own weight set for 40 minutes a week because I only go twice a week. So, but anyways, yeah, you want to, as much as you can, move your body in that natural environment because you're charging up, and then when the movement is just mobilizing energy, getting through that piezoelectric effect, moving it where it needs to go.
Okay, so when it comes to fascia, we've talked about active movement. What about passive, things like foam rolling, massage, where some other inputs coming in, acting upon the fascia? Talk about that aspect.
Yeah, same effect as far as a piezoelectric effect, just more effective for breaking up the scar tissue. Gentle stretching, that's just like our movement, just like in yoga and things like that. That's going to have that piezoelectric energy. You're going to create that. And when you mobilize it, it goes to cells and creates this anti-inflammatory effect. But when we're talking about breaking up fibrotic scar tissue and things like that, yes, foam rolling and that kind of stuff is it creates the piezoelectric effect, but it's more direct in breaking up. It's more of like therapeutic in that nature. But the thing that people miss from that is that's critical in a lot of places, especially if we have trigger points, bound up scar tissue, past traumas, injuries, things like that. It's important to get that tissue worked out, but then the hydration of it afterwards is also very important, because if you don't hydrate those scar tissue, those collagen fibrils, then they're just going to go right back to scar tissue, or they're more likely to go right back to scar tissue. So hydration means being hydrated enough, having enough water, but also infrared light and grounding and things like that, things that increase the amount of structured water that can form on there. So I would say if you went and did some foam rolling or got a massage or whatever, it'd be really great to get sunlight after that, or at the very least do an infrared sauna or a red light panel, do something that can help hydrate the tissue afterwards.
When it comes to fascia, and we could use different words to reference adhesions, scar tissue, changes in the anatomy, how long can it take to work those out using these passive modalities?
Just depends on how deep they are, and how big the scar tissue is, because it could be quite uncomfortable to try and, like, if it's a big nodule or whatever, it could be quite uncomfortable to try and get it all gone in one session. I've actually got some pretty gnarly cupping bruises on my back and my shoulder right now, just from breaking up scar tissue or getting that work done. But it can also depend on how that trauma is stored, and how willing the body is to release it, because trauma can get stored in tissues, mainly from the fact that water can hold memory, and we're largely water. So yeah, how willing the person is to break that up. And so, like, when you get bound up scar tissue in places, it can create stagnant blood as well. Because when fascia is bound up, it can interfere with the blood flow, like not necessarily in arteries and stuff, but like in capillaries and in that interstitial fluid where the blood is, coming in and out, where there's kind of like this swamp. It can create this stagnant area. And so when you break that up, it kind of releases it and gets blood moving through there again. We get new blood in there. So it just depends on how deep it is. But I don't know. I don't do much soft tissue work in my clinic. So you probably ask someone who does soft tissue work more frequently, like how long does it take for the average person? Like how many sessions? Like what's it going to take? But sometimes it's more helpful to have someone else do it than you yourself, because in the process of trying to like foam roll or use a massage ball or something, you're like contracting muscles and getting to these weird positions, trying to stabilize yourself, and you're just not as relaxed and not as willing to let go than when you're just laying there having someone else try and do it.
As a chiropractor, though, having your hands on people, can you actually feel sometimes when there is this bound up fascia? Or is it more theoretical and microscopic?
No, I can definitely feel like it, specifically in joint motion. If there's a lot of bound up scar tissue around a joint or in the tissue surrounding a joint, yes, that joint is not going to move like it's supposed to. And I can feel the difference. At first, I remember in school, like the teachers would tell me, you're supposed to feel this. And I'm like, what? I don't know what you feel. But now I feel, having felt so many spines and so many joints and how they move, it's easy. I can feel when a joint is knocked up and not moving like it's supposed to, compared to the joint below it or the joint above it or something like that. And so, it may take a little work to do that. And it may take some work to get it to stay the way it's moving. If even I create motion in it as a chiropractor or they do something that creates motion in it, it's going to take some training to get it to stay that way. And to retrain the tissue and hydrate the tissue after the breaking up of it has happened. So yeah. But all of that is it's a process, just like anything else, just like changing your diet. Like it's going to take time, for you to do something that's sustainable and make it a habit.
For somebody that this is all new to and they want to begin to get momentum, what are the biggest things they can take on today to start to work towards all this we're talking about?
Yeah. One step at a time. Also, I think that it can be overwhelming to think about all these different things we have to do, which is like a large part of what I do in my health consulting is I'm helping people figure out, okay, what's the priority right now? What's the most important thing right now for you to do? Here's the short-term stuff that you need to do. And then here's the long-term stuff that you need to work on over time, rather than trying to do it all at once and overwhelming yourself and then saying, I don't have time for this or whatever. And that can be hard. Just like when we started off, we talked about like someone with knee pain. What do you do? How do you do? Well, first you have to determine what's causing it. Like, is it been there? Is it just a sensory thing? Is it more cognitive aspect? Because it's been there a long time. We got to figure that out before we're going to be successful about treating it. And so that can be helpful. Like, that's the service I try and provide for people, is like analyze everything that's going on in their life. It's what my form that people fill out is designed to do. So I can be like, okay, this is an issue. This is the biggest issue. Let's focus on this first. Start with that and go from there.
All right, Dr. Hussey, really enjoyed round 2. We're going to link up your books, your social media, your website, everything in the show notes. Thank you.
Yeah, thank you.
Now that you're done, you're going to want to stick around here and catch this other incredible episode. You don't want to miss it. I'll see you over there.
Life is just all about harvesting energy from the environment and using it to create order. And if you don't have enough energy in the system to maintain the order, you get disease. Things start to break down. And so the first place that the body seems to sacrifice is the line.